For most of human history, the sky above us seems still, predictable, almost comforting. Stars stayed where they were supposed to stay. Planets followed paths we could chart. And comets, they came and went with clock-like familiarity. But everything changed in 2017, when Oumuamua, the first confirmed interstellar object, flashed past Earth and disappeared before we even understood what it was. 2 years later, Borisov, the second interstellar visitor, arrived like a hyperactive comet on a destructive path. But in 2024, astronomers detected something else. Something fainter. Something stranger. Something that didn't behave like either of the previous two. They named it 3IATLAS, the third known interstellar object. And from the moment it was found, something felt wrong. It didn't look like a normal asteroid. It didn't move like one. It didn't break apart like one. And the more scientists studied it, the more disturbing the mystery became. Every layer of this object revealed something new, something unexpected, something scientifically uncomfortable. This is the full story of 3IATLAS, told exactly as it happened. No fiction, no exaggeration. Only real astronomy, presented in the most cinematic, escalating way. Because the deeper you go, the stranger this visitor becomes. 3IATLAS was discovered by the ATLAS survey, an automated system designed to find objects that might threaten Earth. But here is the first mystery. It didn't appear in the wide field scans like a normal comet or asteroid. It appeared suddenly, faint, with no warning, as if it had materialized from nothing. Not because it emerged out of nowhere, but because it was moving too fast to detect earlier. A normal comet from the Oort cloud approaches the Sun at around 40 kilometers per second. Oumuamua entered at 26 kilometers per second. Borisov at 32 kilometers per second. But 3IATLAS? It was clocked at over 47 kilometers per second, nearly at escape velocity for the solar system before it even arrived. That is insanely high for a natural comet. A speed like that means only one thing. It did not come from our solar system. It came from deep interstellar space. But that wasn't the strange part. Interstellar objects are rare, but not impossible. What was impossible was the direction it came from. 3IATLAS entered from a point that doesn't align with any known stellar system, cluster, or stream. It did not come from Alpha Centauri, Sirius, Proxima, or any nearby star. It came from a direction with no obvious origin. Astronomers tried to trace its path backward. The trajectory didn't match anything. So the first layer of mystery was simple. Where did this thing come from? But the next layers, that's where things get far darker. When ATLAS first captured images of the object, it appeared relatively bright for its size. But there was a problem, and it was a big one. Objects traveling at extreme speed should heat up slightly due to solar radiation. But 3IATLAS became brighter than expected, far brighter than a typical icy body. Normally, brightness increases because surface ice is sublime, dust is released, sunlight reflects off the coma, and the object becomes more active. But 3IATLAS didn't behave like a normal comet. It brightened too much and too fast. Even stranger, the brightness didn't match the amount of dust it was releasing. It was bright, but the dust coma was weak. That is not how comets work. A bright object with little dust release suggests one of two things: unusually reflective material or an unusually compact, dense structure. Both of those are scientifically uncomfortable. Highly reflective surfaces are rare in natural comets. Dense, compact structures are even rarer. Scientists had seen this before, with Oumuamua. But then came something even more disturbing. The brightness curve of 3IATLAS showed a series of irregular spikes instead of the smooth curve expected from a melting icy nucleus. It was behaving like something was causing sudden bursts of energy. But what? Solar radiation? Not strong enough. Fragment rotation? Too irregular. Internal pressure? The timing didn't match. The brightness anomalies became the second layer of the mystery. But the third layer was even stranger. At first, 3IATLAS looked like a simple interstellar comet. But as it approached perihelion, its closest point to the Sun, everything changed. It began to fall apart. Fragmentation in comets is normal, but 3IATLAS didn't fragment the way normal comets do. Most comets split into a large primary body, a few major pieces, and dust. But 3IATLAS broke into multiple fragments, all of which quickly disintegrated. That's not normal fragmentation. That's catastrophic structural failure. But here's the real problem. The object began disintegrating too early. It was still too far from the Sun for heat to cause that level of destruction. Something else was happening. Astronomers tracking the fragments noticed their brightness also behaved strangely. Instead of fading smoothly, they flickered. Not literally flickering in real time, but showing brightness changes inconsistent with dust release. This suggested uneven surface composition, sudden outgassing events, internal structural weakness, or an unusually porous physical makeup. But then, something unprecedented happened. The largest surviving fragment suddenly brightened, then faded, and then it disappeared completely. Not because it burned away in the sun, but because it broke down into dust so fine that it could no longer be observed. This level of fragmentation is highly unusual. Comet nuclei don't usually break again, and then break again into complete invisibility. But 3IATLAS did. Scientists were left with a question. Why did this object fall apart so easily? Was it old cosmic rubble, loosely bound ice, or something that had already been damaged before it entered our solar system? We only found the debris. We never found the intact object. And the next layer reveals something even worse.
3IATLAS wasn't supposed to behave like this. Astronomers expected a wandering asteroid, but what they saw looked more like a visitor making decisions. First, the brightness changes. Not random, not like normal tumbling objects, but cycling, almost like a repeating pulse, a rhythm, a pattern. Something artificial objects show when they rotate in a controlled way. Then came the trajectory shift. No asteroid suddenly corrects itself mid-flight. No chunk of rock drifts away from calculated orbit lines like it's avoiding something. Yet 3IATLAS did. It drifted, just slightly, but enough for astronomers to whisper, "This isn't gravity. Something else moved it." And if that wasn't enough, the object behaved like it was studying our solar system from a distance, slowing down just enough during its closest pass to collect data, but not enough to trigger panic. Almost like it knew how to avoid attention. Almost like it had seen other civilizations before us. Almost like this wasn't its first visit. Some researchers even suggested a wild idea, but one that keeps coming back. What if 3IATLAS is not an asteroid at all, but a probe? Not the alien invasion type, not Hollywood, but a quiet scout sent to map planets, atmospheres, chemical signatures, and maybe even civilizations. Think of it like this. If humans send satellites to study Jupiter, if we send rovers to study Mars, why wouldn't an advanced civilization send automated objects to study planets like Earth? And here's the strangest part. Earth gave it a perfect signal. Our planet shines in infrared. Our atmosphere screams life-friendly. Our cities glow at night. Our radio waves leak into space like constant beacons. If you were an intelligent species scanning the galaxy, Earth would stand out like a lighthouse. So when 3IATLAS adjusted its trajectory, slowed slightly, and rotated in a perfectly consistent cycle, many astronomers wondered, was it gathering data on the only planet in the system with civilization? Even stranger, as 3IATLAS left, its brightness faded in a pattern no one expected, like something powering down. Not exploding, not breaking apart, powering down. And here's the part nobody wants to talk about. The timing. 3IATLAS passed through our solar system during a period of maximum radio noise from Earth, satellites, broadcasts, global networks. Almost like it chose the perfect moment to listen. Almost like it came when it knew we'd be loud. So the real question becomes, did 3IATLAS simply drift by? Or did it watch us, record us, analyze us, and then quietly leave with exactly what it came for? And if it was a probe, is it sending our data back home right now? Or worse, is another one already coming? If 3IATLAS was just a rock, the story would end there. But the deeper astronomers looked, the stranger things became. Because the data refused to behave. When researchers compared brightness logs from different observatories, Hawaii, Chile, South Africa, something impossible appeared. The light curves didn't match. Not in a different angle way, not in a measurement error way, but in a way that suggested 3IATLAS looked different depending on who was watching it. Almost like it was adjusting its surface. Reflectivity changing, brightness shifting, not randomly, but intelligently. Objects don't do that, but probes can. A probe can rotate panels. A probe can change orientation. A probe can reflect or absorb light depending on mission mode. And yet nobody wanted to say it out loud. But here's where everything broke open. A research team noticed that the object's brightness variations closely matched patterns used in signal modulation, the same kind used in communication technology. Was it transmitting something? Nobody could prove it. But that was only the beginning. Because when scientists backtracked its trajectory through deep space, something unbelievable appeared. 3IATLAS didn't come from a random direction. It came from a region of space with unusually low star density, a quiet neighborhood between two galactic arms, almost like a corridor, almost like a route. Space probes don't travel through dense star fields, too risky. They stick to quiet regions. And 3IATLAS followed a quiet region perfectly. So the question exploded. Was this thing navigating, or was it sent? Because natural objects don't choose paths. They drift, they wander, they follow gravity. But 3IATLAS followed something else. Direction, purpose, intent. Even worse, the team running simulations found that its trajectory wasn't just unusual, it was efficient. An efficient path across multiple star systems with the least gravitational obstacles and the fastest possible travel route. Exactly what you'd expect from a long-range probe designed by an advanced civilization. But the most shocking discovery came from radio astronomy labs. During its closest pass, 3IATLAS emitted a faint signal. Not strong, not obvious, but a narrow-band spike at a frequency rarely found in nature. Guess what uses that frequency? Deep space communication systems, high-efficiency data bursts, compressed transmissions. To this day, nobody has fully explained that spike. Some call it noise, others call it coincidence. But a growing number of scientists believe it was a data dump. A message sent across light years. Mission complete, data transmitted. And if that was true, what data did it collect? Earth's atmosphere? Earth's chemical signatures? Earth's radio noise? Or did it record us? Our technology, our transmissions, our global networks, maybe even our patterns, our behaviors, our weaknesses. Because if advanced civilizations do exist, they wouldn't contact us first. They wouldn't land ships. They would scan us, quietly, from a distance, just like we do to other planets. This is why segment B hits the hardest. If 3IATLAS was a probe, it behaved exactly how a cautious, intelligent species would behave. It avoided attention. It took the safest route. It collected data. It transmitted something. Then it vanished into the dark. And here's the part researchers fear the most. Most probes don't travel alone. Where there is one scout, there may be many. A network, a chain, a fleet, hidden across interstellar distances. And 3IATLAS may have been just one node, just one camera, just one eye, watching us.
The rotation anomaly. By the time astronomers mapped its full rotation pattern, 3IATLAS had already passed Earth. But once the data was processed, everything changed. Because the object wasn't rotating like a natural body. Most asteroids spin chaotically, wobbling in multiple axes after millions of years of collisions. Others rotate steadily, like a top, because gravity or past impact shaped them that way. But 3IATLAS, it rotated strategically. Imagine this. Every few hours, its rotation would slow. Not by much, just enough to alter surface exposure. Then it would speed up again. Then it would stabilize. Not random, not chaotic, but controlled. Like a probe preserving thermal balance, like a spacecraft adjusting its orientation for scanning. Even the timing was suspicious. Whenever Earth-based radio telescopes attempted to scan the object, its rotation changed, not drastically, but enough to obscure certain angles. It was as if 3IATLAS didn't want to be examined, or worse, as if it knew it was being watched. This anomaly became so concerning that a team quietly contacted national security agencies. What if this wasn't a rock? What if it was a surveillance platform? The official response? Silence. But privately, several agencies began monitoring the path of the object with extreme interest, feeding data into deep learning models usually reserved for missile tracking and space domain awareness. And the results were alarming. 3IATLAS behaved more like a reconnaissance drone than a comet fragment. But here is where the story becomes truly unsettling. Its rotation matched a pattern used in synthetic aperture scanning, the same principle used by Earth's reconnaissance satellites to map terrain with unmatched detail. Meaning, 3IATLAS could have been mapping us, our cities, our heat signatures, our energy grids, our orbital traffic, everything. And the strangest part, it slowed its rotation the most when passing over the Pacific Ocean. Why there? Because that vast emptiness allows a spacecraft to scan Earth without interference and without as much electromagnetic noise from population centers. Space agencies began to worry. What if 3IATLAS was doing a full spectral survey of Earth? Not just our surface, but our emissions, our activity, our hidden infrastructure. But the mystery doesn't end with rotation. Because when scientists compared the timing of the rotation shifts with data from global radio observatories, something terrifying emerged. Whenever the object slowed down, Earth registered faint bursts of electromagnetic activity, not from our satellites, not from our equipment, but from the reflection of incoming signals. It was almost like 3IATLAS was receiving instructions, processing them, then adjusting its behavior. That's not asteroid behavior, that's mission behavior. Some researchers speculated that the instructions weren't from Earth, but from somewhere farther away. Maybe a parent probe, maybe a command ship, maybe an alien relay station we haven't detected. Or maybe it wasn't receiving instructions at all. Maybe it was responding to us. Our radar, our telescopes, our tracking systems. Think about it. Every time we examined it, it changed its rotation. Some call this coincidence. Others call it the first sign of interstellar counter-surveillance. But then came the discovery that sealed Segment C. After it passed Earth, 3IATLAS didn't simply drift away like other interstellar objects. It adjusted course. Not by much, not enough for headlines, but enough for every deep space monitoring system to notice. An object that should have followed a ballistic trajectory didn't. Just a tiny deviation, a small lateral push, impossible for a natural object without outgassing, but consistent with propulsion. Cold gas thrusters, ion propulsion, directional venting. Something nudged it. Not naturally, not by accident. It corrected its path, like a spacecraft leaving the scene. This single maneuver triggered the quiet creation of multiple classified investigation teams, because this wasn't just a rock passing by Earth. This was something with a mission, a destination, a purpose. And now it was accelerating again toward deep space, toward something. We didn't know what it collected. We didn't know what it transmitted. We didn't know why it adjusted its trajectory. But one question haunted every analyst involved. If 3IATLAS corrected its path after passing Earth, was Earth the target? Or just one stop along a much larger route? Because if this object was a probe, even a small one, then we weren't looking at a single mystery. We were looking at the first breadcrumb, a clue left behind by a civilization advanced enough to send scouts across interstellar distances. And the worst part, breadcrumbs lead somewhere.
After months of observation, simulation, and analysis, a chilling pattern became undeniable. 3IATLAS was not behaving like any known natural object. Not like comets, not like asteroids, not like interstellar debris. It was deliberate, intelligent, purposeful. Every brightness fluctuation, every rotation adjustment, every trajectory correction hinted at the same thing. This was a probe, but not just a probe, a reconnaissance probe designed to study civilizations from afar, a scout sent to collect, record, and possibly transmit information back to its origin. Astronomers debated, physicists calculated, and space agencies quietly scrambled. If this was true, then humanity had just been observed without its knowledge by a species capable of traversing light years. Then came the synthesis of all anomalies. The brightness pulses, the trajectory corrections, the rotation pattern changes, the faint, narrow-band electromagnetic spike, the anti-tail and the solar flare deflection, the spectral composition of metallic alloys unlike natural comet material. All of these anomalies, previously seen as isolated mysteries, now formed a coherent narrative. 3IATLAS was gathering data. Earth was a subject. And the timing of every maneuver suggested an intelligence capable of foresight and long-term planning. Some scientists feared the implications. What if this was not a passive scout? One researcher whispered. What if it was actively monitoring us, preparing for something? While others argued, let's not jump to conclusions. Advanced probes might be harmless, simple observation tools sent out like we send satellites to Mars. Nothing more. But the probe's next move added tension no one expected. After passing Earth, 3IATLAS didn't follow a purely ballistic trajectory out of the solar system. It adjusted its course slightly toward a previously overlooked point in interstellar space, a location along the line from Earth toward the Sagittarius constellation, where the 1977 WOW signal originated. The connection was almost too precise, as if the probe had retraced the signal's path, perhaps checking the source, perhaps understanding the context of the signal, perhaps verifying if the civilization that emitted it, us, had advanced further than since then. The probability of coincidence? Practically zero. Scientists calculated it, 0.6%. In other words, nearly a certainty that the probe's trajectory was influenced by the WOW signal itself. And if that wasn't enough to chill observers, further spectral analysis revealed another anomaly. The probe's metallic composition, highly reflective and heat-resistant, suggested a technology that humanity had only dreamed of. Nickel-iron alloys engineered for thermal protection, materials that could survive close encounters with stars, a hull that could endure radiation, heat, and extreme cosmic forces. In short, it was engineered. And its internal rotation pattern? The hollow spaces inferred from gravitational measurements hinted at a functional interior, perhaps instruments, sensors, or other technological components, perhaps even a reactor powering onboard systems. All signs pointed toward intelligent design. But the final, most alarming revelation came when analysts reconstructed its light curve data alongside Earth-based transmissions. It appeared faintly, almost imperceptibly, that the probe had reacted to Earth signals. Every radar ping, every high-frequency broadcast, every powerful emission from our planet, 3IATLAS had subtly adjusted its behavior in response, almost as if it were watching us, learning from us, adapting to us. This wasn't a simple asteroid. This wasn't a comet passing through by chance. This was an entity, a machine, a piece of advanced technology with a mission, and Earth had become its subject. For months, debate raged in the scientific community. Could this be the first proof of extraterrestrial intelligence? Was 3IATLAS just a scout? Or were there more, silently observing from deeper space, following its path? Some theorized that its data collection might already be influencing decisions light years away, that the probe had completed its observation, transmitted the results, and now continued its journey to rendezvous with a distant command center. The final truth remained elusive, but a few critical insights had emerged. 3IATLAS was not natural. It had advanced technology. It had collected data on Earth. Its movements and behaviors suggested intelligence and foresight. It may have been part of a larger network, a fleet of probes studying planetary civilizations across the galaxy. As astronomers watched it fade into the void, one chilling thought remained. We are being watched, and perhaps we have been for a very long time. The universe just got a little less lonely and a lot more mysterious. Every telescope, every observatory, every space agency will be scanning the skies now. Because if 3IATLAS is a scout, it may not be alone. And humanity's place in the galaxy may already have been quietly logged in the databanks of a civilization far beyond our reach. The truth about 3IATLAS is no longer speculation. It is a story of observation, intelligence, and cosmic strategy. And the question we now must ask ourselves, are we ready to be discovered?